Hi and welcome to exercise 5 of topic 1. And in this exercise we built on the experiences of the previous exercise where we swapped two variables. Remember? I'm going to quickly retake the assignment. So we need to read two integer inputs. That's changed. Okay, now we know it's integer inputs. And so integers are just numbers without a fractional part. And we have to again swap them before they get print to the screen. So we have one input being read, parsed to an int, so meaning that whatever comes in, he tries to make sense of it by converting it to an integer. So a number without a fractional part, and he's going to do that the second time and save the second number into B. Okay. So this program reads two numbers, A and B, containing the numbers, and then he prints them in the same order. The program first A, then B. So if I were to read in 5 and then 7, he would just print, or it would just print A and B again. Okay. We're being asked to write some code in between that swaps the content of A and B so that we see a 7 and a 5 here. But now we cannot use an extra variable. You are not allowed to create any other variables. Okay. And we have a hint, so make use of the fact that A and B are numbers, and this is more of a math problem than a programming problem. So you can skip the exercise if you don't see the answer right away. But of course, in this solution, I'm going to explain the answer. It's not about seeing the math and then being able to do the trick, because it's just a trick. There's some other message inside of this exercise, okay? And I'm going to explain this at the end. So let's first show you the trick. No, let me first show you the trick. What I'm going to do is this. I'm going to write A becomes A plus B. Let's make sense out of this. If A contains 5, as in my example, and B contains 7, then he's going to assign to A whatever is the value he gets from evaluating the whole right hand side. So this is an expression containing a plus and two simple literals, in this case variable names, so they get evaluated to their content. So A is evaluated to 5, B is evaluated to 7, so 5 plus 7 is 12, and 12 gets assigned to A. Okay, so A now contains 12. And you might say, like in the first swap exercise, well, wait a minute, now we don't lose one value, we actually use 12 now, and we've lost 5 because of the fact that 12 is overwritten in this variable A. So, but did I really lose the 5? Because now I have 12 and 7, right? And out of the 12 and the 7, I can make the 5. So let's, in B, write A minus B. And let's see what that brings us. A contains 12, right? And B contains 7. 12 minus 7 is 5, and that gets assigned to B. So B now contains 5. And of course, now I have the values 12 and 5. I can make 7 out of this by again assigning A minus B, this time to A. Let's see what happens. A is 12, B is 5, 12 minus 5 is 7, 7 gets assigned to A, and now A contains 7. And well, that's of course what we need. B containing 5 and A containing 7. And originally it was the other way around. Okay, so let's see if this works. And I need this one, that's swap 2. Okay. Run it. And yes, there we go. We have green tests. Now, let me explain why this exercise is there. It's not just to show you some math trick. It's because of the fact that this tells you the story of one of the balances, one of the scales we have in programming or in IT in general, in computer technology in general. And that's the fine art of balancing memory for processor cycles. Okay, so on the one hand, in these scales, okay, we have microprocessor time, microprocessor versus memory. If you want, read-only, read access memory. Okay, random access memory. Sorry. So RAM. And this RAM and microprocessing power can be exchanged to some extent. Let me explain between the two exercises. In the first exercise for swap, we used an extra variable. Okay, so we used some memory, and this memory we pay makes for the fact that we have to waste less processor cycles, because in that example we didn't have to do calculations. Okay, and calculations of course cost time in the microprocessor cycles. And so in the first example, where we use an extra variable, we paid some memory to speed up the program, so we did less calculations. In this version, we do more calculations, so we add to the processor cycles, but we save memory because we don't need an extra variable. So we have this balance. We can, to some extent, change a little bit, and we can pay memory to speed up programs. And that's of course a well-known trick that, for instance, web browsers use. Okay, it's called caching. So they use more memory just to speed up lookups, so they don't have to go to the website actually, and they can just take things out of their cache. So that's an example where in IT, in information technology, we use more memory, we cache results, as not to have to recalculate or get the same results again the long way. And the other way around is possible as well. So if we have very few memory in some devices like IoT devices, it might be worthwhile paying some extra processor cycles just to save some memory. But of course this is the other way around, and it's less often used nowadays because of the fact that memory is quite abundant and cheap. So you see most of the time this balance being used in one direction, memory being paid to speed up programs. Okay, so caching. The other way around, where we want to save memory and we slow down programs by wasting processor cycles, is less done nowadays because of the fact that memory is just cheap. Okay, and one thing I'm going to show you finally, I can leave this. And one thing I'm going to show you before we call it a day with this exercise is the usage of a debugger. Okay, what you can do is you can just follow along in the program step by step, and that's of course why it's called a debugger, because most programmers just use it to debug their software and to find errors. Okay, but we're going to just use it as beginners also to just get around programs and understand what's happening. So by clicking on one of the rule numbers, you can actually make a breakpoint. Okay, so a breakpoint looks like this. It's a red bullet, and the whole line is colored red. And then instead of running the program, you can actually debug the program. Okay, so there's a little bug here instead of a triangle, and you can debug the program. And when you do this, let's see what happens. Of course, my program first needs input, so it's going to ask me two numbers. Okay, for that I need to go to the process console, and I'm going to give it 5. Okay, and 7. And now you can see that 5 and 7 are assigned to A and B. So this is what's already done. He's coloring the next line he's going to execute in blue. So meaning that line 25 is going to be executed next, but it's not executed yet. You can just hover over variables like this, and he's going to show you what's inside. So at the moment, when he's about to execute line 25, A holds 5, B holds 7. Okay? You can also see it here. Okay? And you can also see what's going to happen, because we're going to assign to A this expression. So I can actually select this expression, right click on it, and say I'm going to evaluate this expression. So what is A and B going to, A plus B, what is this going to be? What is the value going to be of this expression if we evaluate it? And he's going to show you the result. It's 12. Of course, 5 plus 7 is 12. Okay, and he's going to assign the result of this expression to A. So let's see, I can step over, which is F8, or step into, which for the moment doesn't make a lot of difference, because the difference is going to be shown once we use functions, and we're not quite there yet. So for the moment it doesn't matter. I'm going to use F8. So he's going to execute this line, and watch the A being changed to 12. Okay, there you go. A is now 12. And we can do the same thing once more. Pick the, let's see what's inside. A now is 12, B is still 7. I can see what he's going to make of this expression. Okay, so evaluate expression. He's going to make 5 out of this, and he's going to write this to B. Let's see if this happens. I'm going to push F8 again, and B should change to 5. There we go. And now finally A minus B. I can evaluate the expression again, but it's going to be 7, of course, and it's going to be written to A. So A should change to 7. Let's see if I'm executing this. Yes, there it goes. Okay. And now he's about to print A and B, which I'm not going to execute anymore, but here you see the debugger at work for the first time. So use this tool because it explains you how programs work. Okay. This set, I think we're done with exercise 5. Let's just run the test one more time to see if I haven't broken anything. And we're good to go to exercise 6. See you there.